Okay. So fluorine is the symbol F. Now we want to be careful because a lot of times people will think it's FL. Oh, this periodic table doesn't have it, but the newer periodic tables will show you one of our newer elements is fluorium down here, and that one is FL. So we don't want to confuse those two. Just F. The charge on this one, because it is in the second to last column, remember the last one is 0, this one's -1, this one's -2. So this one, its common charge is -1. And because it's over past this diagonal line, remember this line divides our, this line divides our metals and our nonmetals. The ones up here are nonmetals. Okay, so this one's going to be a nonmetal. Now, our next one is Ca, which we'll find here. So being over on the left side of the periodic table, so we can see that's calcium. Being on the left side of the periodic table, it's a metal. And then being in column 2, column 1 is a +1, column 2 is a +2. So this one is +2. Right? And remember, I told you I'm not going to make you identify metalloid. I have this here, semi-metal, metalloid as an option, but really your options are metal and non. I'm not going to make you put metal. I might give you an example of a metalloid, but tell you it's a metalloid and then just ask you to find the mass of it or something. Okay, this one, Z, most people were able to just identify that's our proton, so that's 22. A is, this is where people messed up. A is protons plus neutrons. So I'm going to look at protons is 22, neutrons is 24, so that's going to be 46. Okay. My charge is protons minus electrons. Protons minus electrons, so that's 22 minus 20, that's a +2. And then I have this example for what I need to put in the form. So I'm not just writing the symbol from the periodic table, I need to put Z and A in there. So Z was 22, A was 46. Now let's say you got A wrong. Let's say you said A was 20. If you put 20 over here, I wouldn't count off for it twice. So you might see on your paper CST, that means you're being consistent. So even though that's technically the wrong answer, I'm not taking off additional points. So usually if you see CST, it's a good thing. It means you didn't lose extra points. All right, now notice this is the first time I'm going to the periodic table. I haven't looked at the periodic table yet. So now I'm going to find element 22 and see that that's titanium. So I'm going to put Ti and my +2 charge there. Okay. Okay, so I had a couple of people who went to titanium and started looking at this here. This is the atomic mass that has a similar name, but it is not the same thing as the mass number. The mass number is always a whole number, and it is not a whole number because we're rounding, it is a whole number because we are counting. So we are counting protons and neutrons, and I'm not going to find that on the periodic table because on the periodic table I'm looking at an average. This is a very particular atom. This atom has 22 protons and 24 neutrons. So that's why it's 46. Sometimes that will be the same number on the periodic table, but if you rounded this one to 48, you would have gotten the wrong number. So you want to make sure that you are not just rounding, that you're counting protons and neutrons, okay? You will see something like that on your test. So if that's something that you struggled with, you know, either sort it out now, or if you're still not quite getting it, come to me and we can work through some examples on that. All right, so I'm first going to give you the letter answers for these. I'm going to pull this away so you can see all of them at the same time, and then I'll go through with some explanations. All right, so this one is going to be C. This one is going to be D. This one is going to be C. This one is C. This one is A. And this one is D. Those are the answers. Now I had somebody tell me that I had graded theirs wrong, so if you would put one of these answers and I marked it wrong, then make sure you let me know. But if you put C here and you circle B here, that's giving me two answers, and that's always wrong. Doesn't matter if one of those is right. That's always wrong. Okay. Okay. So you guys had ions. The other class I asked about isotopes, so electrons differ here. This one was a tricky one, 22 electrons. So a lot of people miss this one. So what we can think about is if I have 22 electrons, how many protons would I have? Well, none of these is neutral. Okay, so I'm going to look at sodium first. Sodium is element number 11. That's the number of protons. And if I subtract off the number of electrons, that should give me +1, right? So protons minus electrons equals +1. Well, that makes this 10. 10 is not 22. That can't be the answer. Okay. All the others are +2, so we can do these all at once. So we're going to say we know the charge on the others is +2. Still on the screen. I'm still on the screen. A little out of focus. So we're going to say protons minus 22 electrons. We're going to figure out how many protons we have. So what does P have to be? For algebra, we do onto one side as we do onto the other. We're going to have 22 to both sides. So it's going to be, I heard somebody say it, 24. So now that I know the number of protons, I'm going to go to the periodic table and look for element 24, and that's chromium. Okay. So that's how we got to that answer. Okay. Down here, this is one that, oh no, you guys didn't have the same one as everybody else. This was just remembering your diatomic elements. So chlorine is diatomic. It's one of those dark green ones over here. Any of the others you want me to go through, you don't understand how we got the answer? Okay, so let's look on the back. All right, if I have a chemical formula, it's going to be one of my pure substances. One element makes it an element. Multiple elements makes it a compound. For a mixture, I have to think about some of my rules of thumb. So this one, orange juice is based in water. So for aqueous things, I want to know, can I see through it? Orange juice, you can't see through. It's opaque. So that makes it heterogeneous. Okay. The other class had salt water. Salt water you can see through. So theirs was a solution. Most of you recognize that photosynthesis is a chemical reaction. A rusting nail is also a chemical reaction. That might have been an example I used in class. What about this one? Well, I have the same chemical formula before and after. I didn't break any bonds. I didn't form any bonds. I didn't have any new chemicals. So this is a physical change. Okay. For our last one, it was really just do the math, do the subtraction that you did in lab. But you're using the law of conservation of mass because you're saying, well, if I know that this side is 9.93, then the total of this side has to be 9.93. So 4.71 plus however much this is going to be 9.93. And so that's saying we couldn't have had more mass, we could have had less mass. And so I think you end up with this being 5.22 grams. In lab, did anybody have the mass of all of the things together add up to more than the mass of your original sample? Most people know, a couple people, yes. So usually when that happens, what that means is you had your sand was wet and you were supposed to dry it off and maybe you didn't dry it completely. So there's a little bit of water. That doesn't mean we made matter out of nowhere. It means you're weighing something that's not part of the products. Same thing with the salt. If you were drying out your beaker and there were little drops of water in there still, it would have looked like there was more salt, but it wasn't really salt. It was water getting out of it. Okay, any questions?